Hey folks, this is the third and final video for the parabola section in chapter 10. So if you go all the way down, please, we're going to go with example number 4. The rest of the examples in this particular video are going to be writing the equation of a parabola. All right, so this first part of example 4 says that we should write an equation for each parabola with the vertex at the origin. So they're automatically telling me that my vertex is at the origin. Now, let me tell you, if you're asked to write an equation and you're given a certain list of things, like maybe the vertex is at such and such, or the focus is at such and such, whatever you can put on a picture, go ahead and draw what you know. And you'll notice I've already done this for you. I was told that my vertex is at the origin, and I was also told that my focus is at the coordinate 0, 3/4. The minute I draw this picture, I automatically can tell that this is going to be a concave up parabola. I can automatically tell that just by the picture. I can also tell what my p-value is. My p-value is going to be 3/4. So just drawing the picture spells that out quite clearly. All right, so let's go ahead. We'll start writing in our equation. We have, remember, since this is an up-down, that our x's are going to be squared. So our first piece is going to be x minus h quantity squared. That's going to be x minus 0 quantity squared is equal to 4 times my p-value, and my p-value is 3/4, times the quantity y minus k. It's going to be y minus 0. Well, you clean this up, and we get an x squared equals 3y. All right, so for the next one, notice that we have a horizontal axis of symmetry. Once again, my vertex is at the origin, and you'll see that I already have a picture. My picture shows the vertical axis of symmetry, and it also shows the vertex at the origin. One more thing is that I have a coordinate going through -4, -8. So I put that on my graph. But since I have the axis of symmetry in the vertex, I also know that I have a mirror image at -4, +8. So I went ahead and put those on my picture as well. Now, the minute I do that, I can tell that this is a concave left. I can also tell that I have to use a y-squared equation. So let's go ahead and start writing our equation. We've got y minus 0 squared is equal to 4 times p times the quantity x minus 0 squared. Now, at the moment, I don't know what p is. Now, when I write an equation, I have to know what h is, I have to know what k is, and I have to know what p is. It's kind of like, if you remember back in circles, in order to write an equation, you had to know h, k, and r. Well, in parabolas, you have to know h, k, and p. So I need to do a little bit of work here. You'll notice that I marked this coordinate as an xy coordinate. So I'm going to take this coordinate and plug it in for the x and the y in the equation that I have so far. So this is going to be -8 squared is equal to 4p times -4. Now the only thing unknown is that p-value, so I can easily solve for p. So it's going to be 64 is equal to -16p. Divide on both sides by -16, and my p-value then is -4. So then this gives me the information I need to be able to write my equation. So notice that I've cleaned some things up. I didn't write y minus 0 squared. I just wrote y squared is equal to 4 times my p-value times x minus 0. Again, I don't need that minus 0 part. Clean up the 4 times p, and you have y squared equals -16x. Now, example number 5 is a little different. It says to write an equation, again, of the parabola with a vertex at -2, 3, and the focus is at -2, 2. Then I'm supposed to graph, and then I'm supposed to give the domain and range. Well, the first thing that I did was I put on the graph the things that I know. I know what the vertex is, and I know what the focus is. So I put those on the graph, and the minute I put the vertex and focus on the graph, you'll notice this has to be concave down because the focus has to be on the inside of the parabola. So I know it's going to be concave down. That tells me then to use the x squared equation, and it also tells me what my p-value is. So I know it's going to be concave down. My p-value has to be negative, and it's going to equal 1 because of the fact that these are 1 unit away from each other. Negative because it's a concave down, and it's a 1 because it's 1 unit away. The focus and the vertex are 1 unit away from each other. All right then, let's go ahead. We can write our equation. So we have x minus negative 2 quantity squared is equal to, remember it's 4 times p, so this is 4 times negative 1. I went ahead and just wrote negative 4 times the quantity y minus 3. All right, so that takes care of the writing the equation of the parabola. Now, let's go ahead and work on drawing our parabola. I already have my vertex in focus. Let's see if we can find an intercept. You want to find either an x-intercept or a y-intercept. And so I chose to find a y-intercept on this one because I knew there would only be one of them. And when you find a y-intercept, you're going to let your x equal 0. So you notice here, when x is 0, I'm going to have a 2 squared, which is 4. I went ahead and distributed my negative 4 here so that I could solve for y. So this is going to be negative 8 equals negative 4y. Divide on both sides by negative 4, and you'll get a y value of 2. So my y-intercept is going to be at 0, 2. But because of the axis of symmetry, I also know that I will have this mirror image point that occurs at negative 4. 2. This one right here is my mirror image point. So then this tells me enough information to go ahead and draw my parabola. And then the last thing I'm supposed to do is give the domain and range. And so the domain is going to be all real numbers, and the range will be from negative infinity up to 3 and including that 3. What exactly does P represent? Well, it just tells me what the distance is from the vertex to the focus. You could also say that P tells me if it's positive, it's going to be concave up or concave right. And if it's negative, it'll be concave down or concave left. All right, 2 more examples then for this video. This one I'm not told where my vertex is, so I actually have to take the time to find it. So you see that you've got the focus is at 1, 2. The directrix is at x equals 4. So you see that I've already written those on my picture. And immediately I can look at my picture and I know that my vertex has to be smack dab in between these two. So if my vertex is smack dab in the middle of these, then it's going to occur, let me see if I can draw this with just a, it's going to occur right here, somewhere in there. So it's going to be at the x value of 2.5, or you could also call that 5 halves. And since my y value is already 2 on the focus, it'll be at 5 halves 2. All right, so I'm getting ahead of myself. So my vertex then is going to occur, I don't know what happened there, at 5 halves or 2.5, 2. And then at that point, I also know that my p-value has to be 1.5. So once again, you can see that these are 1.5 units away from each other. Why is it negative, you say? Well, because I can tell that if my vertex is here, in order for the focus to be on the inside and the directrix on the outside, it has to go concave left. So then this is going to be a negative p-value. All right, so remember, in order to write an equation, you need to have the h, the k, and the p. I now have all of those things. It's going to be concave left. That's a repeat of what I just said. So we'll go ahead and plug that in. So y minus 2 quantity squared is equal to 4 times negative 3 halves times the quantity x minus 5 halves. So go ahead and do the math. Clean up that 4p in the middle, and you've got your equation. All right, looking at point B. So again, I'm writing an equation. This time, my parabola goes through the coordinate 2, negative 4. So I'm going to go ahead and call that an xy value. And my vertex is at 0, negative 1. So you'll see that I have my, I have all drawn that I can possibly draw. I've got my, let's see, this was my vertex. Let me label that. This was my vertex. And then this over here was just my XY. Now the problem with this is I really actually don't know the direction. So I need, this is one piece of information that probably was not written in your notes. And I'm adding this to it. You have to know one more piece of information to know if it's either concave right or concave down, which will then tell you what equation to use. So I'm going to go ahead and just hand you this piece of information. I should have put it in the typed in notes. This parabola needs to be a concave down parabola. All right, so if it's concave down, then I know that I'm going, let's see here. I know that I'm going to have a mirror image on the other side. But let's go ahead and use our h, our k, our x, and our y. We will plug into the equation to solve for our p-value. So just plugging in x's and y's, h's and k's. And I can tell that my p then is supposed to be a negative 1/3. Now that I have my h, my k, and my p, I can write my equation properly. It's the x squared equation because it's concave down. And don't forget that your p-value is negative. So 4 times p is going to end up being that negative 4/3. All right, and I believe that that was the last example, on this particular set of notes.